All right, beautiful people. Today we're talking about more about lines, planes, points, and intersections. And we're going to talk about our central question, which is what are some certainties about points, lines, planes, and intersections? So certainties are things that are guaranteed, right? So we're going to start with this word that we're going to use today. It's called a postulate. Okay, and a postulate is used a lot in math and in science. So postulates are it's a claim that is taken as true. So basically, it's just a claim that somebody made that all of the community agrees is true. So basically, it's like the forerunner before we start making proofs, and it's before we start making hypotheses and before we start making conclusions and stuff. So a postulate is just like a claim that you make about something that the whole community agrees is true. So one of the postulates we're going to talk about today is the 2-point line postulate. I know it's a stupid name, but the 2-point line postulate. So it says that if you have any 2 points, you can create a line. So between any 2 points, there exists one line. Okay, if you think about this one, it actually kind of makes some sense. So if I draw any 2 points anywhere on a piece of paper, I can create exactly one line between them. If I use a straight edge, I can create exactly one line. I can't create a second line or a third line. So every time I create 2 points, I can create a line. So any 2 points creates one line. So that's the 2-point line postulate. So it will always creates only one line. Okay, so a second postulate is the point plane postulate. So this postulate says that if I have 2 points, yeah, that helps create a plane, but it can create infinitely many plane. So I need a third point. So it's between any 3 non-collinear points, there exists exactly one plane. And let's go ahead and remind ourselves over here on the side what collinear means. Collinear from yesterday means that they're on the same line. On the same line. So if they're non-collinear, that means that they're not on the same line. So the third point has to be somewhere off that's not on that first line. Because remember, 2 points will always create one line. So we just have to find a third point that's not on the line. So what I said yesterday also is if you want non-collinear points, then they just need to kind of form a triangle. Doesn't matter what type of triangle, as long as there are 3 points that look kind of like a triangle. So these 3 points have created exactly one plane. They've defined a plane. If I only have 2 points, which make a line, then I can create infinitely many planes because the plane can rotate in a circle. So I know this is kind of hard to visualize. I'll talk about it in class if you ask questions about it. But 3 points is one plane. 2 points is one line. Okay, so these are just some existence rules, and this will always happen. Again, just like the last one. This always creates exactly one plane, and this always creates exactly one line. Okay, so those are the 2 postulates that we're working with today, or that I wanted to define today, and then we're going to spend the rest of the day talking about intersections. Now you already kind of know what intersection means because we talked about it yesterday and we talked about it this morning. An intersection is when 2 or more geometric figures have at least one point in common. So that means a point in a plane, a line in a plane, a line in another line. All of those things can create intersections. It's when those 2 figures have at least one point in common. And a plane and another plane. I don't know if I said that one. So let's talk about sketching first, lines and lines. So a line and a line intersecting. Line and line. So I'm going to draw line 1. It's just going to go like this. Remember, lines have arrows at the end. And then a second line can intersect it at any angle that I want it to, but I want it to intersect at this point. So I'm going to draw a second line right here. So these 2 lines intersect because they share this point, P. Okay, I'm going to add.